The square root of x squared equals x. So in this situation, a square and a square root cancels each other off, so we're just left with that variable. Keep that in mind. And if we square root any perfect squares, I end up getting the whole number. So square root of 4 equals 2, so root 9 equals 3, root 16 equals 4. Keep that in mind as we go over the next 3 questions. And when you see this problem, imagine as if it looked like this. They mean the same thing. So we could just take the square root piece by piece. So let's focus on the 75. All you have to do is ask yourself, can I divide the 75 by any of these perfect squares? And the answer is yes. I can divide it by 25. I can split up 75 as 25 times 3. And those are still in my square root. Any perfect square, I'm going to circle. And then you ask yourself, can I break down 3 any further? Can I divide that by any perfect squares? And for that one, it's a no. So now we're ready to write the simplified version. And this is how I do it. The square root of 25, because that's still inside, is 5. So now I can write that on the outside. Cross things off after I dealt with it. It's just a good tally system for me. The number 3 we're going to keep in the square root because I can't do anything with that. So that's done. Now we move on to x squared. Like what we said earlier, if I square root anything squared, it just cancels out the square. So the square root of x squared is x. I can write that on the outside now. I'm left with a y. I can't do anything with that. So that stays in the inside, and that is it. That is it. Let's move on to the second problem. What if I got a number in the outside, right? Just disregard that for now. We'll worry about it later. Let's focus on this 36 and ask yourself the same question. Can I divide 36 by any of these perfect squares? And if you look at the list, that is a perfect square itself. So I don't even have to do anything. I don't even have to split that up. That I'm just going to circle because it's a perfect square. And the square root of 36 is 6. So I'm going to start writing it on the outside so I don't forget. I just do this piece by piece. So I'm going to put 6 right here, and that's times. So I'm done with that. Imagine m to the 5th power as m squared times m squared times m. The square root of m squared is m. So that's done. And the square root of m squared again is m. That's done. I can't do anything with that last m, so I'm going to leave that inside the square root. So now I'm done with that. Now I got n to the 8th power. And if I do that, that's going to take way too long, guys, so I'm going to give you a shortcut. As long as it's even like that, all you have to do, because that is the same thing as this, you're just seeing how many n squares fit in n to the 8th. So we're really just dividing by 2. 8 divided by 2 fits evenly. That's n to the 4th power on the outside, and that's taken care of. That's the shortcut. So what do we got? Just simplify it. Negative 2 times 6, negative 12. M times m is m squared. N to the 4th power was the shortcut that we just did, and all I'm left with inside the square root is m. Alright, let's try another one with our shortcut. Like what we said, don't worry about that 2p right now. Let's focus on this 8. What perfect square can I divide into that 8? It's obviously that 4 and 2. And I don't think I can break down 2 any further. I'm going to circle the 4 and start taking things out of the square root. So that 2p we're going to put outside. And the square root of 4 equals 2. So I can write a 2 outside. And remember, that's times. So I dealt with that. And the 2 is left over inside the square root. Moving on to the variables. When it's an even variable, it's sweet because all you got to do is divide that 6 by 2. Take that 6, divide it by 2, and we can take it out of the square root, p to the 3rd power. What if it's an odd number, right? So think about it this way. We can write q to the 7th power as q6 times q. They mean the same thing. And now I got an even exponent. Just divide that by 2, and I can write q3 on the outside. And leave that q inside right there. And my last letter, so I'm done with that. My last letter is r squared. The square root of r squared is r. We can write that on the outside. All we got to do is simplify from here. Sorry if my handwriting is bad, but pretty sure you can read it. 2 times 2 is 4. P times p to the 3rd is p to the 4th. Q to the 3rd, r. and inside the square root is 2q. You can probably start doing this in your head and come up with your own shortcuts, but I just wanted you to visualize it. Let's see if you learned something. Try this problem on your own. Pause the video and see if you got the right answer afterwards. If you did not notice that you can divide 48 by 16, which is a perfect square, you can do it in pieces like this. And 12 times 4, 4 is a perfect square, but 12 is not, and you can break down 12 even further to 4 and 3. So 4 and 4, square root of 4 and square root of 4, that's where these twos are coming from. X to the 10th power, the shortcut is all you got to do is divide that by 2. If you're finding the square root, that's where x to the 5th comes from. Y to the 13th, you had to rewrite it as y12 times y. That's y to the 6th with a y in the inside of the square root. Simplify this by simple multiplication and exponent rules, and you got your final answer right here. Hope you know how to do the shortcut and it made sense. If it did, don't forget to like and subscribe, and I will see you on the next episode. Peace.